All right, guys, good morning or afternoon, depending on what class period is. I am going to be walking you through your notes for today through this video. And then when you're finished, you'll have a practice on Delta Math just as usual. Hopefully the notes for today will not be too confusing. I tried to cover the harder stuff last class so that today would hopefully not be too stressful. So first thing we're going to talk about here is zeros of the graph. So a zero is the same as an x-intercept or a root. Okay, there are three separate names, but they all pretty much mean the same thing. So when you're looking at your graph, the x-intercepts or the roots are going to refer to the points where your graph crosses the x-axis. So for example, on this graph, I have 1 at -7. I have 1 here at 1. And then I have 1 over here at 5. Okay. So pretty much labeling the zeros should be pretty simple. They're going to be these points along the x-axis. Okay. Next thing we are going to be looking for is positive and negative intervals. So a positive interval is going to be sections of the graph where it is above the x-axis. Okay, so if you are asked to find positive intervals, that's where f of x is greater than 0, okay, or above the x-axis. So I'm going to go through just with a little highlighter here. If this is the x-axis, then I'm above on this little piece. Then I dip below again, and then I'm above for this piece, okay? So then I just need to list those in intervals. So I would say all of the numbers between -7 and 1. And then I have another chunk here. This is from 5 all the way until the end of the graph. So I would put 5 until infinity. Okay, then remember, whenever you're trying to unite multiple sections of the number line, you're going to use just like a little U or union. Okay. Now, just like positive intervals are above the x-axis, okay, you can probably guess that negative intervals are going to be below the x-axis. Okay, so I'm going to highlight these in pink on my graph. So I see that I am below the x-axis on this chunk and then this chunk over here. Okay, so my negative intervals I have highlighted in pink. Positive intervals I had highlighted in yellow. Okay, so let's list those out. So for my negative intervals, okay, this is -7 till the left end of the graph. So that would be from -infinity until -7. And then my other little pink section of my graph is just right here between 1 and 5. So I would put 1, 5. Okay. All right. So a positive interval means you're above the x-axis. Oops, sorry. A negative interval means below the x-axis. And then I forgot to put, if f of x is greater than 0, that indicates positive. F of x being less than 0 would indicate negative. Okay. All right, so then the other thing that we're going to talk about is increasing and decreasing intervals. Okay, so an increasing interval is going to be where the slope is positive, and a decreasing interval is going to be where the slope is negative. So this is not referring to above or below the x-axis, but the actual direction that the function is going. So look at your graph. Okay, I see that my graph starts off uphill. Now remember, when you read for the slope, you need to start on the left and work your way to the right. So what I would do is think about if this was a roller coaster. Okay, here's your roller coaster. Here's you. Okay, you're going this way. So overall, what's your roller coaster doing at the beginning? It's going uphill until this peak right here, which happens at -4. So I'm going to say from -infinity until -4. My graph is uphill. Now, as soon as I hit the top of this hump, now I'm going downhill all the way until here. I'm going to list this downhill section as a decreasing interval because the slope is negative. So I would say from -4 until that looks like 3. Okay, then pretend you went up the hill, you went down the hill. Okay, then when it bottoms out right here, you're back to uphill. Okay, which means we have one more increasing section from 3 until infinity. Okay. So go ahead and take a look at that next question right below that. Okay, also I will post these notes onto Schoology. So if you do need to go back and watch them, that's absolutely no problem. Okay, come down here to the bottom. First thing it asks me to do is to find all zeros or roots. Okay, remember we said zeros and roots are just synonyms for x-intercepts. So I see I have one here. So that's -3 and -1. Okay, then as I keep tracing, I see that I hit the x-axis one more time over there at 4. Okay, next, I'm looking for f of x greater than 0. Remember, that's a positive interval versus f of x less than 0 would be a negative interval. Remember that positive is referring to sections of the graph above the x-intercept. So if this is my x-axis, I'm looking at this is above. Okay, then it stays above. And then right here, we switch into the negative section. And then I'm back above here on this end. Okay. So let's write our sections for the positive intervals. Okay, which I'm going to still label in yellow. Okay, I see that from the left end of the graph, all the way until -1. So from -infinity until -1, I stay above the x-axis over here. Then I have my little part where it's below. I'm going to skip that for now. And then from 4 until infinity, we have a second section of the graph. Okay, my negative interval is going to be where I'm below the x-axis. And so I noticed that I had this section here that's below the x-axis or a negative interval. So that's staying between -1 and 4. Okay. Then from there, you're looking at increasing intervals and decreasing intervals. So remember that these are referring to the slopes. So increasing interval means that I'm going up the hill. Decreasing means that I'm going down a hill. Remember, pretend you're on a roller coaster. So if you're here, there you go. Okay, flying down the roller coaster. Initially, you're headed where? Downhill. So I'm going to put that for decreasing. So from -infinity all the way until -3. Okay, and then as soon as I bottom out here, I have a little uphill stent from -3 until -2. So between these two marks, this is an uphill. So I'm going to list it here. Then when I get to the top of the hill, okay, this is now another big downhill all the way until where? Okay, it looks like it bottoms out right here at 1. So from -2 to 1, if I have a downhill slope, I'm going to list that as decreasing. And then don't forget your little union. Okay, then when I reach the bottom of this hill, remember, I'm in the little roller coaster. I come uphill and then I flatten out, but then I keep going uphill. Then all of the end of this roller coaster is uphill. So that would be from 1 until the end of the graph. So that would be from 1 until infinity. Okay. So take a look at that, see if that makes sense. Okay, I'm going to go ahead and go on to the next page. Okay, but remember, if you end up needing to watch this as a video later, that's no problem. So one of the things you should now be able to do is identify zeros, positive and negative intervals, increasing and decreasing intervals. Okay, next page. Another thing that you should be able to find are local max and mins. Now you'll notice that I've given you the definitions here for those. Okay, a local max is a point on the graph that's the largest, but only in its own neighborhood. So what that means is it doesn't have to be the biggest everywhere. It just has to be the biggest, like kind of like in its own little area. So, and then same thing for a minimum, it's going to be a point that has, ooh, this should be smallest y value. Okay, not on the whole graph, but mainly just in its own immediate neighborhood. Okay, so if I'm looking at this first graph here, I'm looking for low points and high points. Okay, right here, this would be a local minimum. Because even though it's not the lowest that, let's say, the roller coaster goes, okay, it's still a low point for its area. Okay, you'll notice that I also have one over here. That would be a local minimum. Okay, and then local maximums would be little high points in a specific area. So for example, as I come down to this bottom out part right here, as I come up, this would now be a local maximum. Okay. Then I go downhill, and here, when you flatten out like this does not count as a min or a max. Okay, that is not a min or a max. And the reason why is because if you look at the neighborhood around it, the point at 4 isn't the highest or the lowest. It does kind of flatten out a little bit, but it's not a true high spot or low spot. Okay. Take a look at the next graph. Okay. Try and think about if you have a local max or min on this one. Hopefully you can identify that you do. I have a high point right here. So that would be a local max. And then I have a low point over here. When it dips kind of down at 3, that would be a local minimum. And I'm not going to write those full words out, but you can see the way that it's spelled up here. Okay, one more left. Take a look at the third graph. Okay, hopefully you can see that we have 3 local mins and maxes. Okay, you have 2 maxes. One here and one here. Okay, and notice, even though this one's taller, okay, this one is still the highest for its own little section. So that still counts as a local max. You can have multiple. Okay, then my local min would be this section, right? Or this little dot right here. Okay, where I have like a little low spot where if you're thinking about the roller coaster, it would kind of like bottom out and then turn back uphill. Okay. All right, one more thing that you should be able to find. I'm going to come back up here to the top. Okay, the next thing that you should be looking for is end behavior. Okay, to my knowledge, this is the first that you have seen end behavior in a math class. It's a little bit confusing the way that you write it, but hopefully we can kind of understand what this is referring to. Okay, end behavior is talking about what's happening at the ends of the graph. Now, you'll notice that every graph has 2 ends. You have a left end and you have a right end. So if you are talking about the left end of the graph, okay, you are going to describe that by saying x is approaching negative infinity. And if you think about, if this is the x-axis here, okay, then negative infinity would be on this side. Remember, this is the x-axis. And then positive infinity would be on this side. So if you're talking about the left end, you're going to say as x approaches negative infinity. Okay, versus if you're over here on the right end, you're going to say as x approaches positive infinity. So left end, x is going to negative infinity. right end x is going to positive infinity. Okay, then the second part of that statement is going to be what your y values are doing. Okay, so on this graph, you can see that both of the ends of my graph are pointed up. So then what I would say is, if both of my ends are going up, then I'm going to say that f of x is also approaching infinity. So as x is going to the left end of the graph at negative infinity, my f of x is going to infinity. That means points up. Okay, now let's contrast that with this one right below it. Okay, so I'm still on the left end. So as x goes to negative infinity, but you'll notice that now my left end is pointed down. So instead of saying that f of x, this is my y values, are pointing up, I would say f of x is pointing down. So what this means right here is that my left end, because x is going to negative infinity, points down because f of x is going to negative infinity. So this is like your left end, this is like your down. Okay, versus on this one, you would have said my left end as I go to negative infinity points up because my f is going up towards infinity. Okay. Now let's take a look at the right end of both of those. Okay, if I want to be on the right end, then I'm going to do x approaching infinity. And then I'm going to look and see which way that end is going. So if that end is traveling up, then I would say my f of x is going up towards infinity. So this means my right end points up. Now, if you look at the graph right before that, you'll notice that this end is also pointing up. So I would say as x goes to infinity, my f of x is also going to infinity, like that. Okay. So the answer would be that little part in the box. Okay, this is me like putting what this means, but this would be your actual pre-cal notation. Okay. All right, so let me give you a second there to take a look at the last graph. Okay, so for this third graph down here, okay, remember for end behavior, you're specifically looking at what's happening on the ends of the graph. So I noticed that on this end, okay, which is the left end, as x goes to negative infinity, that tells me I'm looking at the left end. I see that it's pointed down, then my f of x approaches negative infinity. Okay, and so what that would mean is your left end points down. Okay. Now, if I want to be talking about the right end, then you have to think about what would you change? Because I notice here that my right end is also pointing down. But if I'm looking at the right end of the graph, then I don't want my x going back to negative infinity. I want my x to be going to positive infinity. And that tells me I'm tracing the right end of the graph, but my f of x's are going down towards negative infinity. So I'm going to put what that means. The right end points down. Okay. But your answer would be this kind of weird little math sentence right there. Okay. All right. So when you're ready, go ahead and take a look at the next page. You have one more picture. So what I'd like for you to do on the next page is label your end behavior on that fourth graph. We'll check it here in a second. Make sure that you're doing both the left end and the right end. Okay. So this is that next graph. So take a second and label the end behavior. You should be doing a left side and a right side. Okay, to show that I'm tracing the left end, I'm going to say as x approaches negative infinity. And then I'm looking at which way it's pointed, that end is up. So I would say f of x approaches infinity. That would be your left end behavior. Okay, then this end, I notice that my right end is pointing down. So to say that I'm talking about the right end, I would say as x approaches infinity. And because it's pointed down, I would say f of x goes to negative infinity. Okay. So hopefully you got those right. I'm going to put the little sentence underneath it just in case that helps you. Okay, but this would be the left end points up. Okay, left end being this, points up being that. And then this would be the right end points down. Okay. All right, we're getting there. Okay, you have one more kind of random little thing here before we make an effort to tie this all together. So the last thing that we're going to talk about that's kind of another small topic is the degree of a polynomial. Okay, the degree of a polynomial is determined by the highest power in that polynomial. Okay. And then your leading coefficient is going to be the number, okay, that is in front of that term. So for example, if you had, let's say, 5x cubed plus 10x squared minus 8x plus 12. Okay, you would say that the degree would be the cubed. And the coefficient or the leading coefficient would be the 5. So if you want to put, that would be the degree. Because it's the highest of all the listed powers. And then that would be the leading coefficient. The 5, because it's on the term or the x that has the biggest power. Okay, and there are a couple of patterns with degrees that we're going to look at. So if you have an even degree polynomial, okay, which means the highest degree is even, okay, then you are going to have the same end behavior on both sides. Okay, so I'm going to give you a very easy example because you already know at least one even degree, y equals x squared. Okay, and if you think about the x squared graph, we've been talking about that, right? Okay, what way do the ends go? They both go up. Okay. And the reason that they both go up is because that's an even degree polynomial, but the leading coefficient is positive. That's what makes them both go up. Now, if you think about an even degree with a negative coefficient, like let's say negative x squared, okay, well then we talked about all the last 2 weeks that a negative x squared, both of your ends are going to point down. Okay, but either way, if it's an even degree, your ends are doing the same thing. So they're both pointing up if your leading coefficient is positive, or they're both pointing down if your leading coefficient is negative. Okay, so I'm going to put both ends down. Okay, versus this one is both ends up. Okay. But even means that your ends stick together. Positive means they're both up. Negative means they're both down. Now, for odds, it's the exact opposite. An odd degree polynomial would be when the highest power is odd. And they're going to have opposite pointing ends. Okay. So I'm going to give you two odd degree equations that we looked at over the last 2 weeks. Okay, the first one I'm going to give you is going to be regular x. Now you're probably thinking, well, where's the odd number? Remember, x is the same as x to the 1. Okay, another odd number would be x to the 3. Okay, so both of those are odd, and we've been looking at those graphs all last week. Remember that y equals x is going to be a straight line graph going uphill. Okay, because remember, it's like a positive x here, so it's uphill. And if it was x cubed, it's the kind of squiggly graph, but notice that it's also uphill. So you have one end pointed up, one end pointed down, one end pointed up, one end pointed down. Okay. But the reason that those graphs start low and end high okay, both of them do that, is because you have a positive coefficient and they're odd. So you can imagine that if you change it to a negative leading coefficient, instead of having these graphs start at the bottom and end at the top, start at the bottom, end in the top, you're going to just essentially flip-flop that shape. So if it's a negative x or a negative x cubed, then your graphs are just going to be reversed. The ends are still going opposite directions, but you're going to start at the top and trace downhill. You're going to start at the top, but squiggle downhill. So if your ends are going opposite ways, it's odd. And then the direction that it's overall headed, whether it starts low and ends high or vice versa, is going to tell you what kind of coefficient it has. So this is odd because one end's up, one end's down. But it's a negative leading coefficient because it starts high and it ends low. And you'll notice that even though this one's straight and that one's kind of more of a curl, okay, it doesn't matter. Either way, they're both starting high, ending low, ends going opposite directions. Okay. So then it says, go back and label the previous graphs for the degree type and the sign of the coefficient. So let's take a look at the graph at the top of this page. First question I have for you, let me go up to that question up here. Okay, first question is, do my ends point the same way or opposite ways? Well, this one's pointed up, this one's pointed down. That makes it an odd degree. Okay. And then after I classify it as an odd, meaning the ends go opposite ways, I have to say a positive coefficient or a negative coefficient. And that has to do with where it starts and where it ends. Okay, this one starts high and it ends low. Then if it starts high and ends low, that is a negative coefficient. Okay, so that would be odd degree because the ends go apart, negative coefficient because it starts at the top and eventually makes it down on the other end. So it was a start high, end low. Okay, let's go back one page. Take a look at your next graph. We're just going to keep going backwards. Okay, so your next graph would be right here. You'll notice that on this one, both ends are pointed down. And any times that your ends stick together, that's going to be an even degree. How do I know it's even? Because they're both pointed the same way. They're both pointed down. And if they're both pointed down, then I can conclude that I have a negative coefficient. Okay, a negative coefficient. Okay, go up one graph. Okay, so we're looking at this one now. I have one end pointed down, one end pointed up. They're opposite directions. That makes that an odd degree. And then remember, for odd, you need to think about where does it start? Where does it end? I notice that this one starts low on the roller coaster, and then you're going to end high. And if it starts low and ends high, look back at your notes. Okay, a start low and end high makes it a positive leading coefficient. Okay, one more left like that. Go up to the top graph here. Okay, I'm looking at my ends. I notice that both of my ends point up. That makes it an even degree. Because my ends are both pointed the same way. Not only are they pointed the same way, but both ends are pointed up. So that means that I have a positive coefficient. Okay, so both ends up means positive coefficient versus like in the third graph, okay, both ends down meant you have even negative, okay? All right, you guys are doing great. Okay, we are done with the three kind of random things, so now let's practice it. Okay, take a look at the next graph for me, please. Okay, so we're moving forward, hopefully to almost the last couple of questions on your notes. Okay, you have a picture of a graph. Okay, normally I would give you time to do this in class. However, since I'm not there, I'm just gonna go ahead and run through the answers. Okay, first question I would ask you is it even or odd? You would look at the graph and look at the ends. I notice that this end is up, this end is up, that makes it even. Because both ends are up, that means my coefficient is positive. So ends go the same way, they both go up. Next question, you are looking for the zeros. The zeros occur here and here. So that's -5 and 0. Then it says, where is G increasing and decreasing? Okay, remember increasing means a positive slope. Decreasing means a negative slope. So if I'm thinking about myself on that roller coaster, okay, here's my little roller coaster cart. Woo! Okay, hands in the air like you don't care. Okay, there's your graph. You're starting off going which way? This would be downhill all the way until right here. So if that's -2 and that's -3, that would be about negative, we'll say 2.5. Okay, because it's like 2.5, you know what I mean? So then I would say, okay, well then from here to here is downhill. That's -infinity till -2.5. And then for the whole rest of the roller coaster, once I hit that bottom, now I'm going uphill, then that would be from -2.5 until infinity. So that one just has essentially one hill. You have a downhill and then an uphill, and it splits your graph in half. Okay, then it asks you to label your end behaviors. So for me to talk about the left end of the graph, I see that it's pointed up. I would say as x approaches -infinity, my f of x's are going to infinity. And remember, that means that the left end because my x's are tracing backwards, points up because my y values or f of x's are going to infinity. Versus on this end, as x goes to infinity, my f of x's are going to infinity. And so what that would mean is that the right end points up. And this one over here means the left end points up. Okay, so remember, you're kind of writing it in a weird way, but x tells you if it's left end or right end, and then f of x tells you if it's going up or down. Okay, last thing you're asked to do on this question is to label if there is a max or a min. So since I only have this one hill, essentially, I only have one point right here that can be a max or a min. And hopefully we can identify that because that's a low point on the graph, that would be a local minimum. Okay? A local minimum. Okay, so now let's talk about why are we doing any of this? This has nothing to do with what we learned on Tuesday, okay? But actually it does, because when I taught you how to factor on Tuesday, okay, that is actually how you find these x and y, these x-intercepts here. So if you'll take a look at number 4, okay, I'm going to show you what to do on this. Okay, remember that the zeros are x-intercepts, or places where the graph crosses the x-axis, and they're called that because they make your equation equal 0. So if you have an equation like this and you want to sketch the graph, you're going to take this equation, x squared plus 7x, and you're going to set it equal to 0. Okay, then from there, you're going to think about, okay, back on Tuesday, I learned 3 ways to factor. Okay, let me list the factoring ways for you. We learned how to GCF. We learned how to do perfect squares. And we learned how to do the T-chart method. Okay, so if I'm looking at this left-hand side over here, I'm trying to decide which of those methods is going to be most appropriate for x squared plus 7x. Okay, so it's not perfect squares because I can't square root 7. T-chart, you have to have an A, a B, and a C for that one. Okay, so since I don't have an A, a B, and a C, I know it's not that one. Well, then it has to be GCF. So then I would look at that and say, okay, well, what can I take out of both of those? X squared and 7x, those both have an x in them. So I'm going to take my x to the outside. My x squared is going to drop to an x. My 7x is just a 7. So notice this is the part that we just learned last class. And then from here, what you can do is you can say, okay, if these two pieces multiply to 0, then I can set each of them equal to 0 separately. So either x is 0 or x plus 7 equals 0. This is my first x-intercept because it's already solved. Okay, versus this one, if I have x plus 7, I'm going to have to minus 7 on both sides, which means that plus 7 minus 7 cross out, x equals -7. And these are the 2 places on the graph where it's going to cross the x-axis. So this is x-intercept number 1, x-intercept number 2. So now let's sketch a graph of what that would look like. So sketch a little graph for me here. I know my graph is going to hit the x-axis at 0. And then I know it's going to hit the x-axis at -7. So 1, 2, 3, 4, 5, 6, 7. Okay, and then furthermore, I can look at the equation and think about if it's even or odd. So if I'm thinking about this equation here, The highest power that I see is x squared. That's an even degree. Because it's x squared. And then I would say, oh, well, if it's an even degree, I know my ends need to point the same way. And not only is it even degree, but that x squared term is also a positive. Now, how do I know it's positive? Because it doesn't have a minus on it, right? So it's an even degree with a positive coefficient. Well, then I know that both of my ends point up. So I can kind of connect the dots so that both ends point up. Now we'll look at other examples, okay, but hopefully you can see how this all ties together. The even means the ends go together, and then because the x squared was positive, we know the ends point up. Then factoring helps me find these two x-intercepts here, okay? So we're gonna do 2 more examples of that, and then you're done with notes. Hopefully you are not too exhausted. Okay, 2 more left. Take a look at number 5. Okay, first thing I want you to do is identify if this is an even or an odd function. So I notice my highest power is x to the 3. That means that this is an odd degree. And then I also notice that my x to the 3 is a positive coefficient. Now, how do I know it's not a negative coefficient? Because there's not a negative number in front of the x that has the 3 on it, okay? So this means my ends are going to point opposite ways. Positive coefficient means it's going to start low and end high. Okay. Now, the question is, where does this pass through the x-axis? So let's set it equal to 0. Take your equation, x to the 3 minus 9, x, set it equal to 0. Okay, let's review the 3 types of factoring. Okay, we talked about GCF. We talked about perfect squares. And we talked about T-chart, okay, which is the ABC method. Okay, so first thing I'm looking for is if I have a GCF. So look at your terms there, x3 minus 9x. Yes, that has a GCF. Okay, remember a GCF can be a number or a letter. In that case, it is the letter X. So I'm going to take a divide X out of there. I originally had an X to the 3. If I divide it by X, now it's an X to the 2. My 9X, once I take the X out, is just a minus 9. Okay, so I did a GCF. Okay, out of the other 2 choices, I can only T-chart if I have an A, a B, and a C. I don't have that here, but perfect squares, okay, is the next way I'm going to break this down. Let me remind you how to do that. You can only do perfect squares if it's a minus in the middle and both of these are square rootable. So if I square root x squared, I'm going to get an x in each equation. And then if I square root 9, hopefully we know the square root of 9 is plus or minus 3. So I put a plus 3 in one, minus 3 in the other. Okay, then also remember that even though this one could break down one more time, this x is still in the front. So we removed the GCF to get to here, and then we broke down perfect squares to get to here. We did not need to use T-chart. Okay, then from there, I'm going to take each of those 3 points and I'm going to set them equal to 0. Okay, the x in the front could equal 0. X plus 3 could equal 0. Or x minus 3 could equal 0. And now notice that on these 2, I'm going to have to do like a little baby problem solving. Okay, but if this is an x plus 3, how do I solve it? I'm going to just minus that 3 across so that x equals negative 3. And this one is an x minus 3. Well, then to get x alone, I'm going to add that 3 across. So I would have x equals positive 3. Okay. And then one thing I do want you to notice is that if you have a parentheses like +3, do you see how the answer just comes out to be -3? Or if it starts off as a -3, it'll switch to a +3. So pretty much the answer that you get should be the opposite of what you had before. Even on the example before that, do you remember how this one said x plus 7? What did the answer come out to be? -7. Okay, now a 0 means you had like a loner x here in the front. So I always tell my kids, and I'll remind y'all of this next time, but anytime that your x is on the outside, x is outside, then your number's 0. Think like outside 0. You know what I mean? All right, let's sketch the graph. So set it up right here. I know that my graph is going to hit the x-axis in 3 different places. Okay, the first one is it's going to hit at 0. Okay, another place it's going to hit is at -3. And then another place that it's going to hit is +3. Okay. Then from there, remember what I learned, it's going to start low and it's going to end high. So when I connect my dots, I'm going to start at the bottom. I'm going to go up through the first point, down through the second point, up through the last point, so that it starts low and ends high. How do I know my ends are opposite ways? Because it was an x3 with it, which is an odd degree. Okay. All right. You guys are doing, I'm sure, great. One more example, the very last one. Okay, take a look at number 6. First question that I would ask you if I was there in class is this an even or odd degree function for number 6? So you would look at the equation and say, oh, x to the 3, that's an odd. But then look at your leading coefficient. On that x3, it's a -2. That's a negative coefficient. And then I would think to myself, okay, what does that combination lead me with? Well, odd means they're going to go opposite ends. And then a negative coefficient means that it's going to, look back at your notes if you don't remember. Okay, but a negative coefficient means that it's going to start high and end low. Okay. So even without finding the zeros, I know the basic shape of this one. It's going to start at the top, and then eventually it's going to end at the bottom. Okay, but now let's find those x-intercepts. So I have a -2 x to the 3 plus 10x equals 0. First thing I'm going to do is look for GCF, perfect squares, or t-chart. Now, if you're looking at that, you should know this cannot be a t-chart because t-chart requires an A, a B, and a C. So I automatically know t-chart is out. Okay, because I only have 2 terms. I don't have an extra number to have an A, a B, and a C. From there, we're looking for GCF. Hopefully you see that both of those terms can divide by x. And not only can they both divide by x, but 2 and 10 can also both divide by 2. So I'm going to put GCF divide by 2x. Now, technically that's wrong. Okay, think back in your brain on Tuesday. One of the rules I told you is that if the front one is negative, you need to take out the negative as well. So I'm going to take a -2x out to the front. So remember, never leave a negative in the front. So I had a -2x to the 3rd power. If I divide that by -2, my -2 is on the outside, but I'm going to have an x squared left over. Okay, then for my second term here, I have a 10 divided by a -2, that's a -5. You should also notice that your x, even though the 10 did have an x, when I divide by 2x, that x comes out to the front. So it is not going to still have an x in that next version. Okay. So I'm going to put a little check. We did the GCF. Okay, last thing we need to do is look for a perfect square. Now, remember what I told you last class. Perfect squares you can only use if it's subtraction in the middle, and if you can square root both terms. Now, last class, I told you it had to be a perfect square. Okay, however, I'm going to show you something today that it really doesn't have to. Okay, if this is an x squared, if I square root that, it's going to split into an x and an x. And if I square root 5, even though it's not a perfect square, I can still split it up into a plus the square root of 5 and a minus the square root of 5. Okay, and then usually I would have you find what that number is, but I don't have a calculator, so who cares? Okay, and then my -2x from the front is just staying right there. Okay, so even though the square root of 5 isn't perfect, I'm going to still just split it up anyway. So it'll go to an x plus root 5 and an x minus root 5. Okay, then from there, we're going to take those 3 pieces, set them equal to 0. So if I let -2x equal 0, I could let x plus root 5 equal 0. Or I could let x minus root 5 equal 0. And then I'll let each of those 3 chunks equal 0 and find my x-intercepts. Okay, let's start here. If it's x with a plus root 5, how do I get rid of it? I'm going to minus root 5. So plus and minus root 5 cross out. I have x equals 0 minus -root 5 is just going to come out to be my answer. But then remember what I had told you before on that last question. If it's a plus on the inside, your answer should come out negative. Which means on this one, if it's an x minus root 5, then when I add the root 5 across, my answer should come out to be positive. Okay, so if it starts off as a minus in the parentheses, your ending answer should be a positive. If it starts off as a positive, it should end up to be a negative. Okay, then my last one here is a -2x. Okay, if you have a number right in front of the x like that, that's -2 times x, then you're going to divide by -2 to cancel that out. Okay, but 0, even if you divide it by -2 on both sides to cross this out, that's going to just stay a 0. And then remember what I told you, anytime that your x is on the outside like this, okay, x is outside, then that means that 0 is going to be your answer for that piece. X is outside. Okay. And even though it had a -2 with it, it didn't matter because the x was on the outside, your final answer came out to 0. Okay, let's sketch our graph. So my first dot is going to go at 0. That's my first x-intercept. Okay, and then to find out where -root 5 would be, I'm just going to do this on my phone here. Okay, so square roots. Okay, I'm going to take 5, and then I'm sure y'all already knew this, but if you turn your phone sideways, look, you have a square root. Okay, it comes out to 2.23. So I'm going to put this is about -2.23, which means this would be positive 2.23. So then on my graph, I would go over 1, 2, and a little bit of change, -1, -2, and a little bit of change. So this would be the -root 5, positive root 5, that would be your 0. Okay, and then remember for the directions, we said this is going to start high and end low. So that means I'm going to start at the top. I'm going to drop through the first x-intercept, up, and then end low at the bottom. Okay. And you can always check these in the calculator if you need to. Y'all know there are graphing calculators over by the wall. Okay. All right, so that is it for your notes. I'm also going to post a help video if you want to see the questions that I'm going to work through on the practice for today, but I'm not going to make y'all go over it as a class because I feel like probably you can figure it out even without that. Okay? So do your best, and we'll do a little bit of review on this next class when I come back. Y'all have a wonderful day.